Welcome back to Talk Tensors, the podcast that takes a deep dive into the world of machine learning research.
Yes.
And today
Really?
we are looking at a paper called, and this is a mouthful,
Yeah.
Multilingual Performance of a Multimodal Artificial Intelligence System on Multi-Subject Physics Concept Inventories.
It is a long one.
Quite a title.
Yes,
But it's a really fascinating paper. It's asking the question,
it is.
can AI master complex fields like physics?
Yeah, and in particular, it's not just can it master physics in like a general sense,
Right.
but it's can it master physics when presented in different languages and formats. So
Yeah, that's a great point. And the way they tested this is really, really interesting.
yeah, I think it's a really clever study design. They actually tested this AI's physics knowledge
Yeah.
using images of test questions. So it was presented with these visual exams.
Yeah, that's super interesting. It's almost like they're trying to simulate how a student would actually encounter those problems, you know?
Exactly. So they use screenshots of like actual concept inventory questions from physics
Right?
with diagrams and graphs, all that
Yeah.
kind of stuff.
So it's not just like, can it, spit out a textbook definition, but can it really reason about a problem
Yeah.
when presented with it? That's wild.
Yeah, exactly. They use GPT-4o,
Okay.
which is the OpenAI multimodal AI. So
Right, so it can do text and images.
right, that's why
Got
it's so crucial here. Yeah, and they didn't just like feed it the text; they
Yeah.
actually showed it a picture of it.
And I think what's super interesting is that the AI was prompted in English,
Mm-hmm.
but then allowed to respond in any language it chose.
Yeah, that's a really interesting
No,
element of the study too.
That's really cool.
Yeah.
Okay, so before you get too far ahead of ourselves, let's sort of like step back a little bit and kind of like lay out the foundation.
Yeah.
So what were the researchers hoping to discover? Like, what were the main research questions they were asking in this study?
So there were four main research questions.
Okay.
The first one was, how well does this AI perform?
Across different physics concepts.
Yeah, just in general. So
See where it's good and bad.
yeah, getting a sense of its strengths and weaknesses. And then they compared its performance to undergraduate students who had been taught the material. So it's like
So like a head-to-head.
it's a human versus
machine.
machine showdown.
Love it. All right, so we've got that. We've got AI versus student. What were the other two?
The third one looked at language
Okay,
to see if the language the test was presented in had any effect
that makes sense.
on the AI's performance.
Yeah.
So like, does it do better in certain languages? Does it stumble in others? And then the last one
Wait,
was, does including images actually help the AI?
got it.
Or does it make it do worse?
Oh, that's okay. So that's really, those are the four key questions.
Yeah.
So what kind of, like, what data did they actually use? What kind of physics questions are we talking about here?
So they use questions from this really large data set called of physics questions. It's called Feasport. And this is a website that has questions in over 40 languages.
Oh, wow.
It's like
So these aren't just like random
yeah.
physics questions off the internet. They're kind of established.
Yeah, established.
Yeah, vetted
Got it.
concept inventory questions.
Uh-huh.
And to make it even more like a real test,
Yeah.
they use screenshots of like how the test would look
Oh, wow.
on a computer. So the AI has to deal with all the like visual stuff
So all that,
and like formatting quirks.
right, all the stuff that comes with taking a test online.
Yeah, exactly. And importantly,
Yeah.
they didn't specifically train the AI on any of these
Whoa.
specific questions.
Okay.
So it's really like
So it's a true test.
Yeah.
It's like a pop quiz in a way. It's a pop quiz, yeah.
So it has to use what it knows and apply it to this new situation.
right.
Okay. So we've talked about like the setup of the research. Now let's get to the good stuff.
Yes.
What happened? Did GPT-4o pass the physics test?
So, the results are
Drum roll, please.
kind of a mixed bag, and that's what makes it
Oh, interesting.
so interesting.
Okay.
So it actually did exceptionally well in some areas. It even
Wow.
did better than the average undergrad who had been taught the material
Yeah.
in astronomy, thermodynamics,
Right.
relativity, and reasoning.
Wow. It sounds like it's really good at, I don't know, is it like the more theoretical aspects of physics?
That's right, yeah. I
Well,
think
yeah.
that's a
Amazing.
big takeaway.
Yeah.
It seems like, those subjects really rely on knowing things and remembering facts
Mm-hmm.
and using precise language, which is something
Yes.
that AIs are generally pretty good at.
Right. It's like having access to this vast library of, physics knowledge in its digital brain.
Exactly, yeah.
Okay, so it's great at the theoretical stuff.
Yeah.
What about the more practical? Like,
Yeah.
what about the lab stuff?
That is
Did they
where
bomb that?
it really struggled. It really struggled with anything to do with like,
So it can't set up a Bunsen burner or anything?
no,
All right.
it couldn't do the lab stuff.
That makes sense. It's like,
Yeah.
You could read all the books you want about riding a bicycle, but until you get on there and try it, you're not really going to know how to do it.
Right. It's just a totally different
Total different.
type of intelligence.
So even though it's really, got all this cognitive horsepower, it's still missing that. Like, I don't know how to, what's the word?
I think that's a good way to put it. That embodied understanding that you get
Embodied understanding. That's
from interacting
right
with the world.
Okay, cool. So you were about to tell me about the
language
aspect of the study.
So this is where things get really fascinating. It turns out that the language the test was given in really did affect how well the AI did.
Oh, really?
Yeah. And it wasn't the same across all the languages, which was
interesting.
Was so
Okay, so give me which languages did it do well in? Which ones did it struggle in? What's the story here?
Okay, so first of all, it did really well in Catalan, Finnish, French, Italian, Norwegian, and Polish.
Okay.
Consistently high scores in those.
Yeah. Interesting. So those are all languages that have pretty good representation online, right?
That's right. Yeah, I think that's
lots of digital resources.
Good point. The researchers think that might be part of it.
Like maybe it has more training data in those languages.
Yeah, potentially. Yeah.
That's interesting. Okay, so it's like we might be creating this digital divide.
Yeah, I think that's
where some languages are just
a really good point.
More represented, more data, better performance kind of thing.
Might just be better in languages that are spoken.
Makes sense.
By people with more access to technology.
Fascinating. Okay, so those are the ones where it did well. Now give me the flip side. Which ones did it trip up on?
So the AI's performance really dipped in Punjabi and Tamil.
Okay.
And there were even some instances where it started making up answers, like completely made up answers. We call that hallucination.
Whoa, hold on. Hallucination. What does that even mean in the context of AI? That sounds...
Yeah, it's kind of a freaky, weird term. Basically, it means the AI is saying stuff that's just nonsense, totally wrong. Imagine asking a student about Newton's laws, and they start talking about the history of cheese making or something.
It's like a total disconnect.
Yeah, totally off topic.
So it's not just getting the wrong answer. It's it's not even understanding the question.
Exactly.
Okay. Wow. So is there a reason for that? Is it just not understanding those languages?
Right.
Or
so it could be a few things. It might be that the training data for those languages isn't as good, not as much of it or not as varied. Or it could be that the AI is relying on patterns that it's seen in other languages and then trying to force them onto
so it's
languages where they don't really work.
It's like trying to solve a French crossword puzzle.
Yeah.
Using English words.
Exactly.
You're going to get some of them right, but it's not going to work.
It's not going to work.
Yeah. Right. Okay, so that's fascinating that even these powerful AIs can still experience these language barriers.
Yeah.
So it's not just us humans who struggle with that.
Definitely not.
That's really interesting.
Yeah.
Okay, so we've talked about the language side of things. Now, what about the images? Did having those pictures in there actually help the AI, or did it, trip it up?
This is where it gets maybe a little counterintuitive. You would think that giving it pictures would, make it do better, right? Because humans use visuals to understand stuff all the time.
Yeah, we're very visual creatures.
Exactly, yeah. But actually, it did worse. Considerably worse.
What?
Yeah.
That doesn't make sense. You would think, if it had more information to work with, it would do better.
You'd think so. But it seems like it really shows...
How would it do worse?
Yeah, it's showing this big challenge that we're facing in AI. How do you get an AI to understand what it's seeing and be able to, think about the text at the same time?
So it's not just about, perceiving the image. It's about...
it's about
understanding what it represents.
Understanding what it means, and then connecting that to the text,
Wow. Okay, so it's the AI can see all the pieces of the puzzle, but it can't quite put them together yet.
Yeah,
that's really interesting.
A good way to put it.
This is make me think about, how we design tests. maybe if we want to really challenge these AIs and like push their capabilities, we should be using more images.
Yeah.
Not less.
It's like, it's kind of backwards.
It's totally backwards.
Yeah.
Because, traditionally, a hard test has all these, like, crazy equations or this, obscure jargon.
Right.
Maybe we need to, like, start using more visuals to really, like,
Yeah, that would force it to deal with...
Force it to really think.
This really hard problem.
It can't just rely on, memorizing definitions and spitting out answers. It has to actually, like...
Yeah, it has to actually
reason.
Understand.
Yeah, that's wild. I mean, it's so interesting how we take for granted how good we are at looking at an image and understanding what it means.
We just do it.
It's effortless.
Without thinking.
Right. And for AIs, it's like this huge...
The massive challenge, yeah.
That's really cool. All right, so, this has been really cool to kind of explore this research and, see what it tells us about where AI is at right now in terms of,
where it's at and where it needs to go.
Where it's at and where it needs to go.
Yeah.
Exactly.
It really makes you think about how we design assessments,
Yeah.
Not just for AI, but for humans, too.
Totally, yeah.
Like, if we want to challenge AI and get it to really understand the world better, maybe we need to use more visuals.
More visuals, yeah.
Not less.
That's so interesting.
Yeah, it's like we're flipping the script on what makes a test hard.
Right.
Instead of giving the AI all these crazy equations and jargon.
Yeah.
We're challenging it with something that seems simple,
right,
but actually isn't.
It's an image.
Exactly.
But that's...
Understanding an image is so complex.
It is. It is.
When you think about it.
Yeah, we just do it.
Yeah, we don't even think about it.
Effortlessly.
We see an image, recognize objects, figure out how they relate, draw conclusions, like instantly.
It's amazing.
And getting AI to do that, that's a huge challenge.
Yeah. Yeah, it really highlights how remarkable our visual systems are.
Absolutely. This study really shows us that even with all the amazing things AI can do, it's still got a long way to go when it comes to certain types of thinking.
Right, right.
And that's what makes this research so important. It shows us where we've come, but also the challenges ahead.
Right.
It makes us ask these bigger questions about what intelligence really is, the limits of computers, and how perception, language, and reasoning all work together.
Well said, well said.
This has been a really eye-opening look at how AI does on physics tests.
It has.
We've seen its strengths and weaknesses.
Yeah.
And this fascinating connection between language, visuals, and understanding concepts.
Right.
But the implications go way beyond just test scores.
Yeah.
They get to the core of how we learn, how we measure knowledge, and how we get ready for a future where AI is everywhere.
It's a big one.
Yeah, it really gets you thinking.
It does.
If AI can learn physics, even with its limitations? What about other areas of science? Like, are we at the start of a whole new era of discovery, one driven by AI?
That's a really cool thought.
It is, right? Imagine AI not just as a tool for scientists, but as a collaborator, a partner, working together to understand the world.
That's amazing.
It's not as crazy as it sounds.
Right.
We're already seeing it happen in fields like drug discovery and material science, where AI is analyzing huge amounts of data, finding patterns, and even coming up with new hypotheses.
So it's not just about like crunching numbers and organizing stuff. It's about actually contributing to scientific knowledge.
Exactly.
That's pretty mind-blowing.
It really is.
So how would that even work? Like, what would an AI-driven scientific revolution look like?
Well, imagine AI reading tons of research papers, making connections that humans miss, and suggesting totally new areas to investigate.
Okay.
Or AI designing experiments, finding the best parameters, even analyzing the results, so human researchers can focus on the big questions.
It's like having an army of super smart research assistants.
Exactly. Yeah.
Working tirelessly, 24/7, never getting tired.
Yeah.
Processing information at lightning speed. I mean, that could revolutionize scientific discovery.
Absolutely.
Like, imagine the breakthroughs in medicine, energy, space.
Yeah.
It's incredible.
It's really exciting to think about.
And it's not just about speed, right? It's about AI helping us overcome our own human biases.
Yeah, that's a key point.
Like, we tend to get stuck in our ways of thinking.
Yeah, we follow the same paths.
Right.
But AI can come at it with a fresh perspective.
A clean slate.
Yeah, unconstrained by tradition.
Right.
Or limited human intuition.
It's like having a built-in devil's advocate, always pushing us to think differently.
Exactly. And as AI gets smarter, it might even develop its own scientific intuitions.
Whoa, 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 whoa.
Yeah, it's a little wild to think about.
It's like we're creating a whole new kind of scientific mind.
Right. One that operates differently from us.
It's exciting, but also a little scary.
Yeah, for sure.
So, what are some of the downsides? Are there risks to all this?
Of course, any powerful technology has its dangers.
Right.
One concern is becoming too reliant on AI,
Okay.
giving up too much of our scientific control.
Right.
We have to stay critical, question AI's findings,
Yeah.
make sure human judgment and intuition are still at the heart of science.
It's about finding that balance. Right.
Yeah.
Using AI to enhance our abilities, not replace them.
Right.
Pushing boundaries, but still keeping the core of what makes a scientist.
Yeah.
Curiosity, creativity, skepticism.
Exactly. And as we go further down this road,
Yeah.
we need to think about the ethical side too.
Okay.
How do we make sure AI is used responsibly for knowledge? How do we prevent biases from sneaking in and steering science in the wrong direction? These are big questions we need to address.
It's a good reminder that even the most groundbreaking technologies aren't neutral.
Right.
They reflect the values of the people who create them.
Yeah.
We have to make sure those values align with a just and equitable future,
Absolutely.
where everyone benefits from scientific progress.
Well said.
This study, with its focus on AI learning physics,
Yeah,
has really opened up a can of worms in a good way.
it has.
It's a glimpse into a future where human and machine intelligence become even more intertwined,
Yeah.
and where the search for knowledge takes on entirely new forms.
It's both promising and a little daunting.
It is.
We need to approach it with wonder, caution, and a commitment to shaping it for the better.
Couldn't have said it better myself.
This deep dive has been truly mind-expanding.
It has. It has.
We've explored how AI does on physics tests,
Mm-hmm.
considered the potential of an AI-driven scientific revolution,
Yeah.
and grappled with the ethical questions that come with this powerful technology.
Right.
And as always, we've only scratched the surface.
There's so much more to explore.
We encourage you all to keep digging into these questions.
Yes.
Challenge assumptions.
Absolutely.
And be part of the conversation about AI's role in our world.
Great advice.
Until next time, keep those neurons firing
Yes.
and keep exploring the fascinating world of knowledge.
That's a great place to end it.
I think so too. This study, with it focusing on AI and physics, it's like it opened up this whole world of what might be possible, but also the challenges.
Yeah, totally.
Yeah.
Like, it's not just about physics anymore, right? It's like,
Right.
if AI can handle this,
Yeah.
what about other sciences? Could we be like on the edge of a whole new era
Exciting to think about.
of scientific discovery
Imagine,
driven by AI?
yeah, AI not just helping, but
Right.
actually being a partner.
Like collaborating?
Yeah, like a collaborator.
That's wild.
In research, and it's
A
not
true research partner.
it's not that crazy.
Not as sci-fi as it sounds.
Like we see it with drug discovery,
Right.
material science.
Okay.
They use AI to handle huge amounts of data,
And now it's like,
find patterns,
it's going to come up with ideas.
even come up with ideas.
It's not just crunching numbers.
It's not just crunching.
Yeah, it's like, hey, I think you should research this.
Yeah, that's what's so crazy about it.
That's why. So what would that even look like? Like, what would an AI-driven science revolution, how would that actually play out?
So imagine AI reading thousands of papers.
Yeah.
Way faster than we can.
Right.
Finding these connections that we miss as humans.
Yeah.
Being like, hey, you should look into this.
Okay.
Or helping us design experiments.
Okay.
Figuring out the best parameters.
Right.
Maybe even analyzing the data so we can focus on the bigger picture.
It's like
It's
having a superpowered research assistant
an army of them.
Yeah.
Who never sleep.
working 24/7, never get tired.
Lightning fast.
That would change everything.
Yeah. It's super exciting.
So many breakthroughs.
Yeah.
And it's not just the speed.
No, it's not just speed.
It's it can help us with our own human biases.
Yeah, that's so important.
We tend to get stuck in our ways of thinking.
Yeah, we get stuck in ruts.
Right. We follow the same old paths.
We keep doing things the same way.
But AI can come at it
Your perspective
with a totally fresh
is
perspective.
not limited by tradition.
Right. Or our own limited intuition.
Totally.
It's like a built-in, a devil's advocate,
Yeah.
always pushing us to think differently.
Yeah, pushing us outside the box.
And as AI gets even more advanced,
Yeah.
could it develop its own, scientific intuition.
That's what's wild.
To think about.
It's almost like
a whole new kind of mind.
Creating a new species, like a scientific mind.
Yeah, operating differently.
That's kind of scary.
It is exciting.
It's exciting, but also like...
I'm a little scared.
Yeah.
Yeah.
So what are some of the risks? Are there dangers to all this?
I mean, yeah, with any really powerful technology.
Yeah. There's going to be dangers.
Yeah.
One is becoming too reliant on the AI.
Right.
Like ceding our control over science to the AI.
Yeah.
We have to be skeptical.
Yeah.
Challenge the AI's findings.
Question it.
Make sure human judgment is still important.
Yeah, yeah. So it's like finding that balance.
Yeah, the balance.
Right. Between like augmenting our capabilities and not just replacing them.
Enhancing what we do.
It's pushing the boundaries, but still being scientists.
Yeah.
Right? Curious, creative, skeptical.
And as we go further, like the ethics becomes so important. Thinking about, responsible use of AI.
Right.
Making sure biases don't creep in and steer science in a bad direction.
Because these technologies, they're not neutral, right?
No, they reflect our values.
They reflect our values.
The people who build them.
Yeah, so we have to be careful.
Be very careful.
That those values are the right ones.
This study, focusing on AI and physics. Yeah.
It's really opened up these questions about the future.
It's given us a lot to think about.
A future where human and machine intelligence are more and more intertwined.
Yeah.
And the search for knowledge changes completely.
It's a future with a lot of promise.
It's promising.
But also some potential risks.
We need to approach it with,
carefully.
Wonder.
Yeah.
Caution.
Yeah.
And a commitment to making it
good.
Good.
Yeah.
This deep dive, this has been amazing.
It has been a mind-blowing conversation.
We've explored so much.
We've explored the AI's performance.
The AI's performance on physics tests.
The possibility of AI-driven science.
AI-driven science.
The ethical implications.
The ethical implications.
It's been great.
And as always, we've just scratched the surface.
There's so much more.
Keep exploring these questions.
Yeah.
Challenge those assumptions.
Absolutely.
Be part of the conversation.
Yeah.
About AI and its place in our world.
It's an important conversation.
Keep those neurons firing. Yes. And keep exploring the amazing world of knowledge.
And on that note, we'll wrap up this episode.
Yeah.
Thanks for joining us, and we'll see you next time.
See you next time.